Dr. Ranjani Parthasarathy is a professor in the Department of Information Science and Technology, Anna University. Her area of specialization is computer architecture and networks. One of her special interests is Indian language technology systems. She is actively involved in research in all the areas and has over 50 publications to her credit. She has about 25 years of experience covering both industry and academics.
Welcome to the UGC lecture series in computer science. This is a series of lectures on computer networks. Today we will be looking at wireless transmission. So, what we will do today is give you an overview of the technologies that are involved in wireless transmission, so that you become familiar with some of the terms that are used today in wireless transmission. So, let us first start with types of wireless systems that we are generally familiar with. These are terms that you would have heard of. Let me just list those terms. So, we talk about basic groups of wireless systems classified as terrestrial microwave, satellite transmissions, cellular telephone systems, personal communication systems or PCS as it is referred to, pagers, infrared transmissions, short range transmissions, Bluetooth is a technology that you would have heard of in this category, multi-point distribution services. So, we will now take a brief look at the challenges involved in each of these and some of the details of these various transmission systems. So, if we look at the wireless media that is used for transmitting various technologies that we just talked about, basically it is radio and satellite transmission and infrared light that we talk about. All of them use different forms of electromagnetic waves. So, all these basically come under electromagnetic wave transmission, and depending on the frequencies that they use, they get actually classified into different types of transmission. So, we will just take a look at that. So, as we said, radio, satellite transmissions and infrared light are all different forms of electromagnetic waves that are used to transmit data. And typically what happens is each source occupies a different set of frequencies. So, if you look at the frequency range that is used, you can see that starting from twisted pair, coaxial cable and then different types of electromagnetic transmission all the way up to optical transmission, you have frequency ranges starting from 300 hertz to 300 terahertz. So, you can see 300 hertz, 30 kilohertz, 3 megahertz, 300 megahertz, 30 gigahertz, 3 terahertz, 300 terahertz. So, we are talking about a different range of, a large range of frequencies that we have, and depending on the frequency range, we actually classify these as very low frequency communication, which is called as VLF. Then we say LF, which is low frequency, MF medium frequency, HF for high frequency, very high frequency is VHF, then higher than that we have ultra high frequency UHF, then super high frequency SHF, extra high frequency EHF, and then we have ultraviolet light, which is UV. You are probably already familiar with this relationship that we have between frequency and wavelength. So, we have lambda, which is the wavelength, equal to c by f, where c is the speed of light, 3 into 10 power 8 meters per second approximately, and f is the frequency f. So, we may either refer to it in terms of the frequency or in terms of the wavelength, but typically the frequency is the normal reference that we are used to. So, the different frequency ranges that are used by the different transmissions, if we look at long wave radio uses frequencies in this particular range, that is up to 10 power 4 kilohertz is what is used for long wave radio. AM radio, that is amplitude modulation radio that we use, that we are familiar with, that again is used as 10 power 5 to 10 power 6 megahertz. Then 10 power 6 to 10 power 8 is used for FM radio and for TV. Cellular telephony uses slightly higher than that, the gigahertz range. Then you can see that slightly higher than that you have the PCS telephone, and in fact cellular telephone and PCS telephone, they come under what is called as terrestrial microwave transmission. Higher than that we have the satellite microwave, then we have the infrared range, and after that we have visible light transmission, and beyond that we have the ultraviolet light, which are used for X-rays and so on. So, you can see that you have a range of frequencies and different technologies which use these different ranges of frequencies for their transmission. So, as I said, the different frequency ranges that we just talked about, I have kind of listed them out again here. So, as I said, AM radio 10 power 5 to 10 power 6, FM radio and TV 10 power 7 to 10 power 8, terrestrial microwave covers this entire range. Cellular telephones is probably what you may be interested in, 10 power 8, 800 megahertz is normally the kind of frequency ranges used there. Satellite microwave uses 10 power 9. So, you can PCS telephone again uses 10 power 9, can go up to 2 gigahertz in fact, and then you have these different frequency ranges. Okay. So, now when we look at signals being propagated in these different frequency ranges, what are the considerations that we need to look at? So, that is what we will take a look at now. So, we talk about propagation of the signals. Now, in propagation in free space, is always like light, that is, it basically travels as straight lines. So, if we look at the receiving power, that is always proportional to or inversely proportional to the distance between the sender and the receiver. So, the longer the distance, naturally the power received will be lower, and in vacuum it is proportional to 1 by d squared. The receiving power is additionally influenced by a number of other factors. One of them is fading, now which is frequency dependent. We will take a look at what each of these things mean. And then it is also influenced by other factors like shadowing, which is caused because of obstacles that come in between. Similarly, we also have reflection that takes place when you have large obstacles. So, the signal could just get reflected. So, this is something that you could have. Second thing is there are other factors like refraction, scattering and diffraction. So, refraction again, this depends on the density of the medium. So, depending on the next medium that it has to pass through, depending on the density of that medium, your waves could get refracted, something again very similar to light refraction that we are already familiar with, or light could get scattered when there are smaller obstacles. When you have smaller obstacles, it could get scattered. This is another problem we need to deal with. And then diffraction at edges. So, these are some of the factors that need to be considered. Now, another one that happens because of these is multipath propagation, that is, because of some obstacle and because of the reflection or because of scattering, you find that the signal waves that we are talking about, they take different paths for communication and they may end up at the receiver at different points of time. So, as you can see that there are multiple paths. For instance, if I have this as my transmitter and the car here as the receiver, I could have a direct signal coming from here to here. I could also have a signal that is reflected by this medium here, or which is again scattered by this small stop signal that I have over here. Now, all these three different signals, they take different paths, same signal taking three different paths and ending up at the receiver. This again can cause some problems. Let us look at what that will happen. As I said, many different paths due to reflection, scattering and diffraction. All these things that we just talked about now can lead to this multipath propagation. So, when you have this multipath propagation, the signal is dispersed over time. So, it is referred to as time dispersion. Okay. And this can cause interference with neighbor symbols or what is called as intersymbol interference. So, you can understand what is happening over here. So, what we are talking about is different paths, since the signals travel over different paths, they get dispersed over time. That is, the original signal might, or let us say the straight path signal appears at a particular point of time, and the reflected signal could appear a little later. Now, this will interfere with a symbol, a neighbor symbol, that is the next transmission which is coming, which is taking the straight path, because the other one is delayed. So, a delayed signal and an original signal could interfere with one another. So, what we refer to as intersymbol interference. So, this is a problem to be handled. Then the signal reaches a receiver, that is the signal reaches a receiver directly, and it may also be phase shifted. We need to worry about how these two signals, the directly received signal and the phase shifted signal, interfere with one another. We should make sure that they do not cancel out each other. Okay, so that is something to take about. So, you may end up with a distorted signal depending on the phases of the different parts. So, if you have a distorted signal, then recovering the data from that signal becomes difficult. So, we need to worry about these issues. Okay. Another issue to worry about is mobility. Now, typically we talk about when we talk about wireless communication, mobile communication is something that is a very important part of it. So, what is the effect of mobility on transmission as such, on transmission, or I can say on reception of these signals? Now, when we have mobility, what happens is that the channel characteristics could change over both time and location. The signal paths change, different delay variations of different signal paths. The problem that we saw just now is enhanced when you also take in mobility into account, because you are moving. So, that adds to the variations that you have to contend with. So, then different phases of signal parts. So, that again when they add up, we need to worry about whether they are adding up correctly or not. Another problem is fading, that becomes very enhanced when you also take mobility into account. Now, short term fading is normally what we refer to as quick changes in the power received, and additional changes in the distance to sender and obstacles farther away could lead to slower changes in the average power received. So, for instance, you can understand it from this figure. So, if you look at the power that is received, you may find that there is a variation in the power that is received. Now, this is a short, you can see that these sharp variation that we have is referred to as short term fading. Now, on an average, if you look at the power that is received, you will find that there is again a variation in the power received, which is referred to as long term fading. So, when the power received varies, naturally the reception has to be done correctly, because if the power is too low, then you do not receive it correctly. If it is too high, it could damage your equipment. There are various other things to be dealt with. I mean, I am not going into the details of that, but you need to be familiar with these terms, that there is something called short term fading and long term fading, which is caused basically by the variation that we have in the power received. And all these are issues that one needs to handle when you are looking at wireless transmissions and reception. Okay. Now, coming to some of the details of each of these different transmission technologies that we talk about, terrestrial microwave for instance, let us take a look at what happens in terrestrial microwave transmission. Now, terrestrial microwave transmission is typically land based and it is line of sight transmission. So, approximately 20 to 30 miles maximum between the towers, and then data is transmitted at about hundreds of millions of bits per second, and this is popular with telephone companies and for business to business transmissions. So, typically you have a tower that most of you must have seen a tower like this. So, a tower which is used for transmission, and then you have antennas which are located on top of towers or on very tall buildings. So, often the microwave antennas, as we said, are on towers and buildings, and you have line of sight communication between the transmitter and the receiver. So, this is what happens in terrestrial microwave transmission. Now, if we look at satellite microwave transmission, this is similar to terrestrial microwave, except that the signal now travels from a ground station on earth to a satellite and then back again to another ground station. So, we use satellites as intermediate points, right. So, that you transmit to a satellite and then you receive to another ground station from the satellite. So, the satellites again can be classified by how far out into the orbit each one is. So, we have these different classifications, we have LEO, MEO, GEO and HEO. So, we will just take a look at what we mean by these terms. So, you can see what we have here. Now, this is Earth and I have a LEO orbit over here. This is a low Earth orbit, that is you are not too far away from the Earth. So, it is called as a lower Earth orbit, typically 100 miles is the distance that you have. Then you have medium Earth orbit, which is your MEO transmission. GEO stands for geosynchronous Earth orbit, that is it is synchronous with respect to the position on the Earth. So, it moves such that it's always at the same point, a satellite is always stationed at the same point above the Earth. So, that is called as GEO satellite. Then you have highly elliptical orbit, which is the HEO orbit that is used. Depending on which orbit the satellite uses, you classify that as a LEO satellite or a MEO satellite and so on. You can see that GEO satellite will be positioned at about 22,300 miles away from Earth. Okay, so, that is the kind of or 36,000 kilometers away from Earth. So, if you look at satellite, so continuing on this, so you can see that LEO uses 100 miles to 1000 miles is the range that is used, and this is used for pagers, wireless email, spatial mobile telephones, spying, video conferencing, all these are applications which use this LEO satellites. Middle Earth orbit, as I said, this range goes from 1000 to 22,300 and it is used for GPS and by many government related applications. GEO satellites, as I said, geosynchronous orbit, so 22,300 miles is used for weather, television and government operations. HEO, highly elliptical orbit, is used for spying and by scientific organizations for photographing and celestial bodies and so on. So, when satellite is far out into space, it takes photos. When satellite is close to Earth, it transmits data. So, this is typically what is done when you use a highly elliptical orbit kind of a satellite. So, we take a small break now and come back and continue with the further details. Welcome back after the break. So, we are just talking about satellite communication. So, you could look at what is happening here in terms of a highly elliptical orbit satellite. So, the satellite typically when it is farther away from the earth on the orbit, it kind of takes pictures of these celestial bodies, and when it comes closer to the earth, it transmits the data to the earth. So, this is something that we see in a HEO kind of satellites. Satellite microwave can also be classified by its configuration, that is whether it is a bulk carrier, it is used for bulk carrier, or it is a multiplexed configuration, or whether it is a single user earth station configuration. For example, our VSAT uses this particular mode. So, you can see what happens here. A bulk carrier satellite configuration, you have user connected to a ground station, and then you have a bulk carrier satellite which is used to connect up to ground stations. A multiplex satellite configuration would be that you have multiple users connected to a ground station, and the transmission to the satellite from the different users is multiplexed. So, that is your multiplexing mechanism that is used here. Single user earth station satellite configuration is you have multiple users directly connecting up to the satellite, and from the satellite you connect up to the different users. So, these are different configurations that could be used for satellite communication. Okay. Now, coming to another kind of transmission which is called as millimeter wave transmission. Now, this corresponds to extremely high frequency ranges, EHF, which is 30 to 300 gigahertz. Now, this is the problem with these frequency ranges is that they are highly susceptible to absorption. So, really cannot use them for very long ranges, you can use it only for short ranges. But they have a very interesting usage that they are used in radio astronomy, remote sensing, security screening and medicine. Now, these are two applications that again is more commonly seen by most of us, security screening and medicine. So, whenever we go through airports or whatever security checks, the security screening is done by means of millimeter wave transmission. Similarly, in medicine, for as medicine again millimeter wave transmission is also used. Okay. Now, coming to infrared transmissions, these are basically special transmission that use a focused ray of light in the infrared frequency range. Again, this is something that we use almost on a daily basis when we are using your remote to control your TV and so on, we use infrared light. So, this is again very common with remote control devices, but can also be used for device to device transfers. For example, from a PDA, from a personal digital assistant to a computer, you could use infrared communication. Okay. Now, coming to mobile telephones, now this is something we will pay a little more attention to, because this is technology that we are using on a very regular basis. So, mobile telephones, if you look at, we talk about a wireless telephone service such as cellular telephone, cell phone, what we refer to, PCS, all these come under the domain of mobile telephones. Now, again this to support multiple users in a metropolitan area network, for instance, the network or the market as such is broken down into cells. Now, each cell has its own transmission tower and set of assignable channels. Now, this is what gives it the name of cellular telephony. In fact, we talk about our cell phone, the name cell basically comes from the fact that the entire network area is divided up into small cells. So, if you see what happens, if this is your entire area, you can see that it is divided into small cells. Each cell will have its own transmitter, and the different devices which come within the transmission range will use that tower for doing the transmission. So, this is what you will have. You could have land based telephone lines which connect up these towers or these MTSOs as they are called, okay, to a local telephone company, and then this is how you integrate between your landlines and your cell phones as well. Okay. So, from the MTSO it goes to a tower which is located within each cell, and from the cell you can talk to the different users who are there in that particular cell. So, this is an overview of what happens in cellular telephony. Okay. So, just a picture of a mobile telephone tower, what it could look like. Okay. So, let us look at what happens when we need to place a call, and similarly when we need to receive a call. So, to place a call, what you do typically is you dial a number, and the dialed number is transferred via the setup channel. So, you will have something called a setup channel that is used, and the user's account is checked for validity. Then the MTSO assigns a channel for the connection, that is a channel on which you need to be doing your data transfer or your voice transfer. Okay. So, the setup channel is now released and the assigned channel is now seized, that is you get hold of that assigned channel, the channel that is assigned for your communication. Okay. The system then proceeds to place the call. Okay. Okay, this is what happens. To receive a call, we will see what happens here. When someone calls your cell phone number, the call is not broadcast all over the country. Instead, it is just sent to that particular cell. That is, the cellular phone system knows where your phone is located within a cell and broadcasts only within that particular cell. Okay. So, within that cell, so it is broadcast, and since you are present in that particular cell and you know the channel on which you have received the communication, you are able to pick up the particular whatever voice is being communicated to you. So, this is what happens. Talking of different terms that we use with mobile telephony, now you must have heard this term AMPS, which is commonly used with mobile telephones. We talk about Advanced Mobile Phone Service, AMPS. Now, this was the first popular mobile phone service, and this uses analog signals and dynamically assigned frequency division multiplexing. Then we have something called DAMPS, which is Digital Advanced Mobile Phone Service. Now, this applies digital time division multiplexing on top of AMPS. So, basically it is AMPS, but the signal transmission takes place using digital time division multiplexing. And remember, we have talked about time division multiplexing and many such schemes earlier. So, those are the schemes that are now used in these for the actual transmission in DAMPS. Okay. Then we have PCS, which is Personal Communication Systems, newer all digital mobile phone service, what was also referred to as the second generation communication system. Now, PCS phones they typically come in with three different technologies. We use TDMA, which is time division multiple access, which basically uses time division multiplexing. Then we have CDMA systems, which are code division multiple access. These basically make use of using different codes for the transmission. So, this is code division multiple access. Then we have GSM, which stands for Global System for Mobile Communications. This is another standard that is used. Some phones are dual banded, and then we have the 3G or the third generation wireless, which can be used for internet, data access and so on. So, these are some of the commonly used current technologies that we have. Okay. Now, another technology that comes in this wireless domain is Bluetooth. Again, another useful technology. We use this for short range communication. So, Bluetooth, as I said, it's a radio frequency specification for short range, point to multi-point voice and data transfer. You could use it for voice transfer and for data transfer. The more commonly used Bluetooth communication these days is for point to point data transfer, typically from a cell phone to a cell phone. If your cell phone has a Bluetooth connectivity, so from your cell phone to another cell phone, you could just transmit your cards and so on, right? Your visiting cards can be transferred using Bluetooth. So, this is something that the technology behind it is what we need to look at. So, this can transmit through solid non-metal objects, and its typical link range is from 10 centimeters to 10 meters, but can also be extended to 100 meters by increasing the power. So, this is the frequency ranges used in Bluetooth. So, what this allows you to do is that it enables users to connect to a wide range of computing and telecommunication devices without the need of connecting cables. So, that is a major advantage of this Bluetooth technology, that you do not need the connecting cables, you just use the wireless media for doing your data transfer. So, typically, as I said, it is used in phones, pagers, modems, LAN access devices, headsets, notebooks, desktop computers and PDAs. All these use the Bluetooth technology. Okay. Another wireless technology that again is of importance to us is the wireless LAN or the IEEE 802.11b technology that we talk about. This is basically used for transferring data between workstations and local area networks using high speed radio frequencies. So, Wi-Fi is a term that you would have heard. This basically uses a standard called IEEE 802.11b, and this is what we use currently for our Wi-Fi connections and so on. Okay. Then we also have what are called as broadband wireless systems. That is, we are talking about broadband connectivity using wireless. So, here we are talking about delivering internet services into homes and businesses using wireless technology. So, this again is designed to bypass the local loop telephone line, can be used for transmitting voice, data and video over very high frequency radio signals. Okay. So, this is a picture of what you would have when you have a broadband communication using wireless. So, you have what is called as a broadband switching center. Now, this would be connected to some long distance connectivity, or it could be connected to internet and so on. Now, this will be connected to base stations. Now, these base stations typically would be located on top of some tall building or towers, okay, and you could have high speed lines which connect up these kind of base stations, okay. And these base stations again now would be connected by, they would have a base station antenna and a transmitter, and this will be connected using wireless transmission to different businesses, homes and so on. And these homes and businesses would have the corresponding antennas located on top of their buildings. So, from here to here the communication takes place using wireless, and this wireless media can handle broadband data. So, when I say broadband data, I am talking about audio and video data which requires a higher bandwidth, right. So, this is something that we have, okay. This is the kind of setup that we have for when you have a broadband transmission. So, broadband wireless systems, if you look at the technologies that are used over there, they use two basic technologies. One is called as multi-channel multi-point distribution service or MMDS as it is referred to. So, you can see what it means. It has multiple channels and it will support multi-point distribution. So, it supports digital data, video, internet access at millions of bits per second. This basically works at 2.5 gigahertz, 30 to 35 miles is the range that is covered by this technology. Then we have something called local multi-point distribution system, LMDS. Now, this is again for data, video and internet access, and this uses a data the frequency range of 28 gigahertz to 30 gigahertz, but you can only transmit data to a few miles. So, which is why it is a local multi-point distribution system. Okay, this is what is used in wireless systems. So, to summarize, what we have looked at is an overview of various wireless transmission technologies. So, we have looked at different frequency ranges and their uses. We have looked at the challenges that come up in signal propagation in wireless transmission. Then we looked at types of wireless transmission systems. We have looked at different wireless transmission systems starting from terrestrial microwave to broadband wireless systems. So, questions to review the material covered today. Question number 1, which frequency ranges are termed as low frequency and which is ultra high frequency? Question number 2, what are the factors that cause the received signal to be of lower power? Question number 3, what is fading? Question number 4, what are LEO, MEO and GEO satellites? Question number 5, how does the cellular communication work? Question number 6, what are the technologies used for PCS? So, these questions should help you to understand or review the material that we have looked at today. Thank you.